Kukira dia menyukaiku, menyukai. Sana tak ada hutan di balik batu. Hujan badai akan ribut, dekatiku kan merasa bosan. Menyukai. Sana tak ada hutan di balik batu. Hujan badai akan ribut, dekatiku kan merasa bosan.
Assalamualaikum and hi. We continue our discussion on definition of Laplace transform. In the previous video, I've told you about the definition of Laplace transform for only one function, where the function defined over the interval of 0 to infinity. Okay, so that we can simply apply the definition, okay, here, the integral here, and then we substitute whatever function ft that we have inside the integral, okay, and then we try to integrate, okay, and then we finally reach the solution in S domain. Okay, and then we can try to compare to the table of Laplace transform either we get the same solution or not. Okay, so now we want to apply the definition once again, but this time we don't have only one function which is defined over the interval of from 0 to infinity, but over the interval 0 to infinity we have many functions. We have a piecewise continuous function. Okay, we can say that the function is one piece, another piece, and another piece. Okay, so that is a piecewise continuous function which is still defined over the interval of 0 to infinity. If we can see the limit here, we have from 0 to t. Okay, so t starting from 2 and above. Okay, goes something else. Okay, so that we can say that it end up at infinity. Okay, so instead of writing t is equals or greater than 2, so we can also write like this. Okay, so that it is met our definition, which is over the interval from 0 to infinity, from 0 to infinity here. Okay, so in order to solve the piecewise function by using the definition, it is just the same thing. Okay, so by definition we have the integral from 0 to infinity e negative st ft dt. So this is our integrand. Okay, so e negative st is consistent as e negative st, but ft from 0 to infinity is divided into small pieces. Okay, so that from 0 to 1, okay, from 0 to 1 e negative st, what is our ft when we have from 0 to 1? Oh, 0, so we substitute 0. Okay, and then we cannot stop yet because this our limit must meet our definition from 0 to infinity, so we go on lah. Okay, so next we stop at 1, so we start again at 1. Okay, until 2. Okay, our ft is 1. Okay, 1 here, yes, we are correct. And then plus from 2 to where? To infinity. 2 to infinity. E negative st is consistent or remain unchanged as e negative st, but our ft here from the limit 2 to infinity is 2, so we put 2. So we just apply we just do the integration. Okay, just apply the same technique as we have discussed in the previous video. Just solve for the integration. Okay, so that we will come up with the solution in complex frequency domain or in S domain only. No more function in t, no more in time domain. Okay, so this is our solution, okay, written here. Okay, so someone might ask, Doktor, Madam, boleh ke kita nak compare dengan table of Laplace transform? Okay, for example, okay, from 0 to 1 is 0, so probably you get 0 lah kan, plus, okay, plus From 1 to 2, you have ft equals to 1. Oh, ft equals to 1, this one is a lah. So you have 1 over s plus, okay, this one for this limit you have 2. So 2 ni a juga. Okay, so you have 2 over s. So this is totally wrong. Why? Why I say that you are doing the wrong thing? Because of what you can see in your table. I repeat, okay, what you can see in your table, a t to the n, e a t, sin a t, and the rest is a function where it is defined over the interval of from 0 to infinity. Okay, this a, okay, is from 0 to infinity. This t to the n is from 0 to infinity. Unfortunately, for your function here, your a here, okay, is not from 0 to infinity, but this one is from 0 to 1, 1 to 2. This one is starting from 2 to infinity, so that it is not met our definition from 0 to infinity, so that you cannot simply referring to the table of Laplace transform. So what you need to do is you still need to apply the definition in order to get the equivalent function in complex frequency domain or in S domain. Okay, so table of Laplace transform for piecewise continuous function is not applicable, right? So during our class, we already test your ability to refer to the table of Laplace transform. For example, if I have my a, okay, let's say my ft equals to -5, so that the equivalent function in S domain is -5 over S. Let's say my ft equals to t square. So t square we will refer to the t to the n, okay, where n is 2, so that we have 2 factorial over s2 plus 1, so that you have your fs is 2 times 1 over s cubed, which is 2 over s cubed. Okay, and then we have, let's say my ft is exponent 3t, okay, so that our fs, okay, Laplace ft or your fs is this one, 1 over s minus a. Where, what is a? A is 3, so s minus 3. Let's say my ft is exponent -40. So what is a? A is not 4, but a is -4. So Laplace ft, okay, is fs. So what is my fs? If my ft is e -40, so I have 1 over, refer this one, s minus a. S minus, your a is -4, so that you have +4. Okay, so the same will follow if you have sine, cosine, sine hyperbolic, and cos hyperbolic. So we will discuss about the properties in the next video. Okay, so I really hope that you can get a good idea about what is the Laplace transform. Okay, what is the inverse of Laplace transform. That is just a general idea. Okay, so our main target is we want to solve for initial value problem. Okay, and then from these 2 or 3 videos, I really hope that you can understand very well about the definition of Laplace transform. Okay, the definition for the single function, which is defined over the interval 0 to infinity, as well as for the piecewise continuous function. Okay, for the piecewise continuous function, other than I give you in the form of piecewise continuous function like this, I can also give you a function which is I try to visualize the function, the piecewise continuous function, so like this. So my question is find fs. Very simple. Find fs or find Laplace ft by using the definition. Okay, if I don't mention about the definition of Laplace transform, you have no choice other than apply the definition. You must apply the definition. You cannot simply refer to the table, because of this function is a piecewise function. Okay, so let's say this one is 1, this one is 2, okay, and this one is, let's say, so sorry, this one is 3 lah. 1, 3, and then this one is 4, okay, and then this one is 6, for example, okay, and then this one is 1, and then for the t, okay, t exists, I have this one is 2, this one is let's say I put this one is 3, like this, okay. Okay, so in order to get the fs or Laplace ft, what you need to do is, you know that fs can be obtained by definition, okay, integral from 0 to infinity e negative st ft dt. So the question is, what is your ft? Okay, so what is your ft? So this is your ft lah, so that you need to find out your piece by piece function here, okay. So your ft, you must come out with the piecewise function like this first, then only you can solve, okay. So this one is, I just write ft equals to what, okay, within the interval of from 0 to 2, okay, from 0 to 2, t from 0 to 2, okay, ft equals to what, ft equals to what, from where your t from 2 to 3, okay, and then ft equals to what here, okay, t is greater or equals to 3, or you can simply write this one as like this, okay. So this one ft is uniformly 3, okay, uniformly 3 from the interval 0 to 2, so I can simply write like this. And this one is also just the same graph, okay, but this one is at 1, okay, your ft equals to 1, your ft equals to 1 consistently, uniformly, okay. So within this interval, okay, within this interval, okay. So what about this one? This one is, you cannot simply say that this one equals to 4, this one equals to 6, no, cannot. So what you need to do is, here you need to recall what we have learned previously about the linear graph, okay, about the linear equation, y equals to mx plus c, okay. So that your y here is ft, okay, so m is m, okay, m is m, so x is t lah, ni kan, okay, plus c, okay. After you get y equals to mt plus c, ft equals to mt plus c ni, okay, so that you take mt plus c, ft ni kan, ft equals to what, equals to mt plus c, so substitute lah sini mt plus c tu dekat situ, that is your function lah, okay. So how to get m, so how to get c, that is your task, okay. So if you have any problem on how to get this one, try to discuss with your friend, or otherwise you can reach me at any time. Inshallah, I will try to help you, okay. So please do the exercise 1 here, okay. This one is very simple. I hope that you can do this one, okay. So class, thank you very much for your attention, for your spirit, for your positivity about our math 2. So I hope that after this we can discuss about the linearity, first shift, and multiplication by t to the n. Laju sikit lah, okay. So thank you very much. Assalamualaikum and bye.